Welcome back, dear children. Now we will move to section B of our chapter current electricity. Okay, I think we have learned about a cell. What is the chemical? What happens actually? What is the energy transfer in a cell? A cell converts chemical energy into electrical energy, isn't it? And again, what is the use of a cell? Why are we using a cell? A cell is used in order to provide a potential difference, isn't it? If there is a potential difference between the two electrodes or ends, then only current flow will take place. So in order to maintain a constant potential difference, we are using a cell. And inside a cell, actually chemical energy gets converted into electrical energy, isn't it? Now, when you are taking a cell, it actually consists of a beaker, and in that two electrodes will be dipped in an electrolyte, isn't it? So let this be a cell. So we will be having the beaker. Inside that, what is present? Electrolyte is there, and then two electrodes will be dipped inside in the electrolyte. So this is the structure of a cell. Now, chemical reaction takes place inside this, and as a result of this chemical reaction, a constant potential difference will be maintained between the electrodes of a cell. Okay. Now we will check how this potential difference is maintained. So suppose I am taking a cell. So for the cell we have the two electrodes dipped in an electrolyte. Let this be copper. Okay, this be the copper electrode and this be zinc. So two electrodes are taken and let the electrolyte be dilute H2SO4. Okay, now dilute H2SO4. So actually what happens when sulfuric acid is mixed with water, it dissociates into H plus and SO4 2 minus ions, isn't it? So sulfuric acid in water dissociates into H plus and SO4 2 minus ions. Now, these SO4 2 minus ions will move towards the zinc electrode and it will give electrons to the zinc. Okay, SO4 2 minus will move towards the zinc electrode and it provides electrons to the zinc. That means the number of electrons present in zinc will be more. So it develops a negative charge. Similarly, H plus ions will move towards the copper electrode and this is positive ion. It attracts the electrons from the copper electrode. So what happens? Electrons are moved from this, so this will become positively charged. So, copper is a positively charged electrode. What is the name given for positively charged electrode? You learned it in chemistry, isn't it? It is known as anode. And the negatively charged electrode is known as cathode. So, one electrode will become positively charged and the other will become negatively charged. That means in one there are more number of free electrons or electrons and in the other there are less number of electrons. So a potential difference is maintained in between the electrodes. Now, is it an open circuit or a closed circuit? What is an open circuit? Open means no current flow takes place in the circuit. Here we are just having two electrodes dipped in an electrolyte. I didn't connect it, isn't it? And no current is flowing through it. So that means it is an open circuit. So in an open circuit, that is when no current flow is there, the potential difference between the electrodes can be called as EMF or electromotive force. It is represented by the letter epsilon. EMF or electromotive force represented by the letter epsilon. So, it is actually a potential difference. So, its unit is volt. Okay. So, is it clear? Once again, I will tell you. We know that a cell converts chemical energy into electrical energy, isn't it? Now, the two electrodes dipped in an electrolyte makes a cell. Due to chemical reaction inside the cell, what happens? A constant potential difference is maintained between the electrodes. Now, I have taken a cell. So, copper and zinc are the electrodes dipped in dilute H2SO4. Now, sulfuric acid in water dissociates into H plus and SO4 2 minus ions. SO4 2 minus ions will move towards zinc and it provides electrons to the zinc. So that means zinc will become negatively charged. H plus ions will move towards copper and it accepts electrons from copper. That means this becomes positively charged. So we have positively charged anode and negatively charged cathode. In one we have more number of electrons and in the other we have less number of electrons. That is, a potential difference is maintained between the two. And here no current is drawn from the cell. That is, it is an open circuit. So in an open circuit, when no current is drawn from a cell, the potential difference between the electrodes can be called as EMF or electromotive force. It is represented by the letter epsilon. Okay. And its unit is V. Volt is the unit. Now, when we are connecting a bulb or something, here, if I connect a bulb or something, actually current flow will take place through the external circuit also and then the bulb will glow. Okay, so if current flows through it or if you are connecting the two electrodes. Now, we have one more definition for EMF. It is the work done to move a positive charge around the entire circuit. Okay, that is inside as well as outside. How much work is done in order to move? Flow of charges makes electric current. In an electrolyte, due to the movement of positive and negative ions, we will be having the current flow. In the external circuit means it will be due to the movement of electrons. Here ions will be moving in the inner part, but in the outer part when you are connecting, what happens? Electrons will flow from cathode to anode. That is current flow. When we say current, direction of current, it is opposite to the direction of flow of electrons. So when you are connecting these two electrodes, here, if you are giving the connection, then electrons will flow from zinc to copper. That means current flow take place from copper to zinc. Direction of current is opposite to the direction of flow of electrons, isn't it? So, here the flow of electrons is electric current, isn't it? So, the work done in order to move a positive charge across the entire circuit can be called as EMF. So this is another definition for EMF. How much work is done in order to move a unit positive charge? We know that positive charges can't move, but almost all the definitions are based on the movement of positive charge. And earlier I told you what is the reason, because conventional current and electronic current, isn't it? Earlier it was believed that movement of positive charges makes electric current, and almost all the definitions are formulated on the basis of that. Okay. So is it clear? The second definition, that is the work done in order to move a unit positive charge through the entire circuit. Entire circuit means inside the cell as well as when you give a connection outside the cell. That is known as EMF or electromotive force. Now, the EMF or electromotive force depends only on two factors. It depends on the nature or the material of the electrodes as well as the electrolyte. Okay. So, it depends only on two factors, which are the material of the electrodes as well as the electrolyte. So, is it clear about EMF? Now, here no current is drawn from the cell. if you are giving a connection in between the electrodes, I am connecting, what is this? This is a resistor, isn't it? So if I am giving a connection between the terminals, then it becomes a closed circuit, isn't it? And in a closed circuit, when current, that is when current flows through a circuit, the potential difference between the terminals can be called as terminal voltage. Okay. So what is that? Terminal voltage. What is terminal voltage? It is the potential difference between the electrodes when current is drawn from it. That is, if the external circuit is there, when current flows through the circuit, the potential difference between the terminals across the outer part. Okay, here we will be considering only the external circuit. So that potential difference can be called as terminal voltage. Okay. Then one more thing related to epsilon. From the second equation, we can make from the second definition, we can make an equation for EMF. EMF was work done to move a charge. So epsilon will be W by Q. Okay. Epsilon, work done to move a charge. So W by Q will be epsilon. Now about terminal voltage, I told you, if the connection, that is if the circuit is complete, if it is a closed circuit, when current is drawn from the cell, what is the potential between the terminals? That can be called as terminal voltage. It is represented by capital V. Okay. It is represented by capital V. Here it is also a potential difference. That means its unit will be volt. Okay. Unit is same, but it is represented using the letter capital V. So is it clear about terminal voltage? Now similar to EMF, we can give one more definition for terminal voltage. Okay. It is the work done to move a positive charge across the terminals of the electrolyte or the cell. Sorry, across the terminals of the cell. Okay. That is, in the case of terminal voltage, we will consider only this outer part. We won't consider the inner part. The work done to move a unit positive charge across the terminals in the external circuit can be called as terminal voltage. It is represented by the letter capital V. So here what can I write? Capital V. Here it is also the work done. So I will put it as W dash by Q. Okay. So this is the terminal voltage. Now one more thing is there. That is, in the case of EMF, we consider the outer part as well as inner part, isn't it? Outer and inner parts are considered in the case of EMF. But when you are considering terminal voltage, we will be considering only the external circuit. So which one is greater? EMF or terminal voltage? Which one is more? EMF is greater, isn't it? In the case of EMF, it is the work done to move a unit positive charge through the entire circuit, inner as well as outer. Terminal voltage is the potential difference. Sorry, it is the work done to move a charge through the external circuit. So, EMF will be greater than terminal voltage by how much? Work done to move the charges through the inner part. Did you understand? In the case of EMF, we considered the entire circuit. How much work has to be done to move a unit positive charge through the inner part? Inner part means through the electrolyte and outer part means externally connected circuit. Okay, so both these things are coming in the case of both EMF. But when you are considering terminal voltage, it is the work done to move a charge through the external circuit. There we considered only the external circuit. So which one is greater? Epsilon is greater than terminal voltage, isn't it? By how much? That is the work done to move the charges through the electrolyte. So the work done to move the unit positive charge through the inner part or through the electrolyte is known as voltage drop. Okay. How much work is done in order to move a unit positive charge through the electrolyte, then that is known as voltage drop. It is represented by small letter V, and here I'll write W, small letter W by Q. So this is the third thing, that is voltage drop. Okay. So I'll repeat these three things. EMF means how much work is done in order to move a positive charge through the entire circuit. That is, inner part means through the electrolyte, outer means when it is connected, when connections are given externally. That is EMF. It is W by Q. Now the work done to move a charge through the external circuit is known as terminal voltage. It is represented by capital V. So V equal to W dash by Q. Then voltage drop means the work done to move a positive charge through the inner circuit, that is through the electrolyte. So I'll write it as small letter V. It is W by Q. Now how can we relate these three things? How can we relate? Can you tell me? Three equations I told you. So keeping these three equations and three terms, how will we connect? So this I keep as such, W by Q. I need only these three equations. So which one is greater here? It is epsilon. This is equal to capital V plus small v. Okay. Epsilon is the EMF. EMF, two definitions are there. First definition was in an open circuit, potential difference between the terminals is EMF, or it is the work done in order to move a positive charge through the entire circuit. Okay. Outer as well as inner. That is EMF. Terminal voltage V means it is the potential difference between the terminals in a closed circuit. Or you can say that the work done to move a unit positive charge through the terminals in the external circuit. So V equal to W dash by Q. Then voltage drop is the work done to move a positive charge through the electrolyte, which is W by Q. So epsilon is equal to capital V, terminal voltage plus voltage drop. Okay. So this concept is little bit difficult to understand. So what you have to remember is when you are taking a cell, inner part current flow takes place due to the movement of ions. Outer part നമ്മൾ ഇലക്ട്രോൺസിനെ കണക്ട് ചെയ്യുകയാണ്, എക്സ്റ്റർണലി വയർ കൊണ്ട് കണക്ട് ചെയ്യുകയാണെങ്കിൽ അതിലൂടെ കറന്റ് ഫ്ലോ നടക്കുന്നത് ഡ്യൂ ടു ദ മൂവ്മെന്റ് ഓഫ് ഇലക്ട്രോൺസ്. ഓക്കെ. അകത്ത് അയോൺസ് കാരണം, പുറത്ത് ഇലക്ട്രോൺസ് കാരണം. ഇനി ഒരു പോസിറ്റീവ് ചാർജിനെ മൊത്തം സർക്യൂട്ടിലൂടെ മൂവ് ചെയ്യിപ്പിക്കാൻ വേണ്ടിയിട്ട് ഹൗ മച്ച് വർക്ക് ഹാസ് ടു ബി ഡൺ, ദാറ്റ് ഇസ് EMF. ഇനി ഒരു പോസിറ്റീവ് ചാർജിനെ പുറത്തുള്ള, I told you this is the cell, ഇതിനെ രണ്ടിനെയും കൂടി കണക്ട് ചെയ്യുമ്പോഴത്തേക്ക് ഇതിലൂടെ മൂവ് ചെയ്യിപ്പിക്കാൻ വേണ്ടിയിട്ട് ഹൗ മച്ച് വർക്ക് ഹാസ് ടു ബി ഡൺ ടു മൂവ് എ ചാർജ് ബിറ്റ്വീൻ ദീസ് ടു ഇലക്ട്രോൺസ്. ഇതാണ് ഔട്ടർ പാർട്ട്. അവിടേക്ക് ഉള്ളതിനെയാണ് വി വിൽ കോൾ ഇറ്റ് ആസ് ടെർമിനൽ വോൾട്ടേജ്. ഇനി ഈ വഴി കൂടി മൂവ് ചെയ്യുമ്പോൾ ഹൗ ദ കറന്റ് ഫ്ലോസ്, ഒരു ക്ലോസ്ഡ് സർക്യൂട്ട് ആണെങ്കിൽ ഒരു എൻഡിൽ നിന്നും മറ്റേ എൻഡിലേക്ക്, ആൻഡ് ഇറ്റ് വിൽ ബി, ഇറ്റ് ഇസ് എ ക്ലോസ്ഡ് സർക്യൂട്ട്, സെയിം പോയിന്റിലേക്ക് അത് തിരിച്ചെത്തും. സോ ഔട്ടർ പാർട്ടിലൂടെ പോകുന്ന ചാർജ് കൊണ്ടുപോകാനുള്ള വർക്കാണ്. ഇറ്റ് ഇസ് ദ ടെർമിനൽ വോൾട്ടേജ്. ഇന്നർ പാർട്ടിലൂടെ ഉള്ളതിനെയാണ് വോൾട്ടേജ് ഡ്രോപ്പ് എന്ന് പറയാം. Okay, so EMF is the work done to move the charges through the entire circuit. Terminal voltage through the external circuit. Voltage drop through the electrolyte. Okay, how much work has to be done? So please go through this, study this concept, then only I can move to the next portion. You should be thorough with EMF, terminal voltage and voltage drop. EMF means the entire circuit, terminal voltage, outer circuit, external circuit, voltage drop in inner part or the electrolyte. Okay, so please keep this in mind.